Good afternoon. Today we are going to talk about concentration stoichiometry. So as of this point, you may have identified types of reactions. You may have looked at predicting products for chemical reactions. This particular presentation, you don't have to have gotten those pieces nailed down before you learn. However, when you go on to the next concentration lesson, you're going to need to remember your predicting products stuff. So this slide deck is going to help you with learning about concentration, as I already said. And we're going to define solute, solvent, concentration, and molarity, how to calculate the concentration, molarity of a solution, and how to use the concentration of a solution in a Stoich problem. That's actually going to be saved for another video because that's going to be a little bit higher level. Quick note here, I live by train tracks, so I'm going to try to do this when the trains aren't passing, but hopefully the trains aren't going to be too much of an inconvenience for this video shoot here. All right, definition, solution. Solution is what we consider a homogeneous mixture of two or more substances. So the big classic example of a solution is Kool-Aid. You've got your Kool-Aid mix that is a solid, but when you put it in water and stir it up, it turns into a solution. And it does not seem as if you can pull apart the Kool-Aid from the water. You can't see that there are two substances, two or more substances dissolved into each other. We say that the substance is uniform in nature, meaning any sample that I take from the solution will look the same. So here's some examples here. Here's some Kool-Aid. Olive oil is a solution of many different triglyceride fats. And air is a homogeneous solution or a homogeneous mixture because it's going to contain nitrogen, oxygen, and other gases, but you can't tell them apart from each other. So components of a solution. The solute is the substance that's going to be dissolved into the solvent. The solvent is the substance that does the dissolving. In most cases in chemistry, that's going to be water. And the solution is the combination of the two. So I chose the example, a very timely example, I feel, where I have my packet of emergency every morning. I'm a firm believer that's a good thing to do in our COVID age. Here is my emergency, that would be my solute, and my solvent would be the amount of water that I pour the emergency into and stir to get the solution of emergency. So, by the way, this was my last packet of emergency about 3 weeks ago. Stores have all sold out, so I'm kind of out of emergency. So if you know of an extra stash, tell me about it. To calculate concentration, it's a really simple formula. Concentration is also called molarity because the definition of concentration is how many moles of solute you have in a given amount of solvent. The formula looks just like this. C is concentration. Concentration has the units of moles per liter. How many moles of the substance can go into how many liters. And so notice we're not going to deal with grams here. We're going to deal with moles. So we have to remember how to convert mass to moles. The lowercase n stands for moles and capital V stands for volume. Notice down here that the units for volume have to be in liters, have to be in liters. So if I give you a problem in milliliters, please convert to liters by dividing by 1,000. Move that decimal 3 places to the left. There are 1,000 milliliters in a liter. IB does not use L for liters. They use cubic decimeters. And so you will see this symbol here as well, dm to the -3. It's the same thing as a liter. It's 10 centimeters times 10 centimeters times 10 centimeters is going to be equivalent to a liter. So here's your formula. I'd pause the video here and write down that formula, highlight it, and put it into your notebooks. they would give you some formulas on the IB exam. This is not one of them because they're assuming that this is simple enough for you to remember. So, tricky tool to use in order to use that very simple equation is the molarity triangle. So you notice here that you've got this triangle with concentration in the lower left corner, volume in the lower right corner, and moles up top. And the formula was N divided by V, so this part of the triangle. So in order to use this, what you need to do is cover up the variable that you're trying to solve for. So for example, if I'm solving for moles, I cover up the mole and I find that the C and the V are next to each other, so it turns into concentration times volume. If I want to solve for volume, I notice that the moles is on top of the concentration. So to find volume, I divide moles by concentration. If I want to find volume or concentration, I use the formula as I gave you on the previous slide. There's moles divided by volume there. So if you don't want to rearrange and isolate the variable every single time, just an easy trick to use in order to calculate whatever variable you need to for the concentration formula. So let's say you'd like to, and this is going to be an example problem here. Let's say you would like to create 150 milliliters of a 0.1 mole per liter solution of sodium nitrate. How would you do this? What I'm going to do now is I'm going to play this little video for you. And this is going to be available, of course, besides in this video format. So you can always pause and come up with questions or take some notes.
So here's an example problem using C equals N over V. Let's say we would like to create 150 milliliters of a 0.1 molar solution of sodium nitrate. How can I do this? Here's your equation, C equals N over V. I'm just solve for the number of moles in solution. So to rearrange this equation, isolate N. For my values, I need to remember to convert my volume to moles. All I need to do here is remember there's 1,000 milliliters in a liter, so I just move the decimal to replace them on the left, representing 2 zeros in 1,000. Solve this out, and I find out the number of moles of sodium nitrate that are in the solution, or 40.15 moles. I can't put moles on the scale, so I need to convert moles to grams. By the conversion factor of the more mass over volume. So pick up my mass again, that wants to be nitrogen, oxygen, so more mass of 85 grams per every mole. So multiply 0.15 moles by 85 grams, and it equals 8 grams of sodium nitrate in 150 milliliters of water. So that's how we can use that. But it is a good formula, and definitely sure in order to get the sodium nitrate to dissolve. And dissolve pretty readily because all the dissolve in water.
Okay. So hopefully that example made a little bit of sense. If you have any questions with that, jot them down and you can add them to the assignment at the bottom in the comment section. All right, so with that being said, you're going to have some practice to do. You're going to find a Mr. Gutch worksheet at the very bottom here. This is, again, just round one of simple concentration problems. And then the next video segment is going to show you how to use this concentration equation with some stoichiometry. If you recall the stoichiometry highway that we had a couple weeks ago, before everything did whatever had happened, you'll notice that there was one place on the stoichiometry highway that we haven't used yet, and that's where C equals N over V. You'll see that on that highway that you have copied down somewhere in your notebook. And that it's time now, we're going to use that. But that's going to be in the next video segment. All right, as usual, don't hesitate to ask any questions. I'm going to be available on Thursday of this week at 1 o'clock and Monday and Thursday, 1 o'clock next week. So have a wonderful rest of your day.